Hmm. 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 Just Hmm.
All right, I guess we'll go ahead and get started. So good morning, everyone, and welcome to today's episode of MAE Industry Insights with Gator Grads. My name is Mitchell Parker, and I am a current graduate student here in the UF MAE department. It is my pleasure to be moderating this morning's event and introducing our guest, Shawn Martin. Mr. Martin graduated from the University of Florida in 1986 with a bachelor's degree in mechanical engineering and from the U.S. Naval War College in 2006 with a master's in national security and strategic studies. He also received training in 1988 as a U.S. Navy scuba diver and in 1994 as a U.S. Marine Corps combat diver from the Naval Diving and Salvage Training Center in Panama City, Florida. Mr. Martin began work at the Department of Defense in 1987 with the Naval Surface Warfare Center, Panama City Detachment, as a mechanical engineer. Mr. Martin was assigned in 1997 as a Navy Engineering Liaison to the Directorate of Science and Technology at U.S. Special Operations Command. Following completion of his master's in 2006, Mr. Martin was assigned to the U.S. SOCOM Small Business Innovation Research Program as the program manager. His next assignment was division chief of the Special Operations Special Technology Program, which focused on developing, demonstrating, and transitioning technology to the warfighter. Mr. Martin was hand-selected in 2010 to be a plank owner of the Undersea Systems Office. He held positions as the technical director, deputy program manager, and finally technical program manager. In 2019, Mr. Martin was selected to be the deputy program manager of the Special Operations Forces Lethality, where he currently works today. In his distinguished career thus far, Mr. Martin has been the recipient of the Joint Civilian Service Commendation Award, the UFMAE Outstanding Alumnus Award, as well as multiple US SOCOM awards. To tell us more about his exciting and diverse career, I'm going to turn it over to Mr. Martin.
Hello, everybody. Again, my name's Shawn Martin. And for the short period of time we have today, what my intent is to provide you a bit of an overview of my background, in addition to what Mitchell just stated, some of the projects that I've worked on throughout my career, not all of them, just highlight some of them from the list that I show, and then get down to lessons learned. So hopefully it'll be beneficial. And so let's get started. So again, background, project highlights, career lessons learned. So as Mitchell said, most of this he already said, if you will, but I wanted to, on my work experience, I didn't go to college right after high school. I actually worked for the railroad as a laborer for a few years doing manual labor in the shops, and decided that I needed to do something different with life. So went to UF, went through school and got my ME degree, sorry, in 1986. I worked for Southern Bell for 1 year. And the reason why I highlight that is because I couldn't stand the job. I worked there for a year and decided this was not for me. It didn't suit my personality and what I wanted to do. So I think in general, for students coming out of school, it's important to understand your first job may not fit you well, and that's okay. Just keep seeking and look for something that does. So I moved on to the Navy, worked for them in a lab for 10 years in Panama City Beach, and then down to U.S. Special Operations Command for the last almost 24 years now in the Acquisition Technology and Logistics Center. So I'll move on. So one of the things I also talk about at times is technology readiness level. My entire career has largely been about technology development. Some people get out of an engineering college and they go into, it could be engineering sales, it could be supply chain management, it could be quality assurance, it could be a variety of aspects or design. And so mine was more on the development design of new systems, new capabilities. So, and that spectrum, understanding your technology readiness level of components and subsystems is so important. This is a scale, a term, a system developed by NASA years and years ago that was adopted by the DoD quite a few years ago. So move on. So a list of projects, this is not all of them. And you can see that they are vast in scope. From the sealed delivery vehicle Mark 8 Mod 1, I had a hand in that design, to oxygen transfer pump assemblies, flyaway recompression chambers, transparent armor, etc. So I was either doing the actual design work myself or got into a position of that I was overseeing other people doing work. And that's what I'll highlight through in additional in this presentation. What aspect of that was, I didn't stay a design engineer my whole career. So one of the first design projects I had many years ago, and I'm talking 30 years ago, was to develop the surface propulsion system for this hybrid prototype boat we called the Seal Submersible boat. And it was a one-of-a-kind beast. It held 2 crew, 8 passengers, if you will. Would do about 35 knots on the surface. Then it had a subsurface capability as well. So the trick was to develop a surface propulsion system that would work on the surface and survive below the surface, submerged, and not take up too much size weight in the process. So I had a lot of constraints on the design. So this is the submersible engine that I came up with. We're doing a test dive with it. We're down about 75 feet, and I had it suspended from a crane on a surface craft. And what we were doing was we're trying to do a controlled experiment here. And so I didn't have to work on this. The craft I was using was a surrogate craft, not the final parent craft. And so I was testing its suitability for the application. So that's me with the white fins on. That's part of the reason, one of the benefits of going through Navy dive school, I could actually dive on my projects that were subsea. That's the engine, the power head for my design that I came up with. It was a free flooding engine, which worked reasonably well. I designed these drain valves in each of the combustion chambers, and that's a custom made head and so forth. I was awarded the patent for the drain valve and the design of the engine, and it worked reasonably well for the application. So this project here, the Seal Submersible boat, I was a design engineer. I was a test engineer on it as well. So I kind of took it from initial concept through design, through fabrication, verification of performance, and we were into the validation steps working with a SEAL squad when it was destroyed, actually. This is a follow-on craft. I was at U.S. Special Operations Command in the Science and Technology Directorate, and a company licensed the patents for not only the craft, but also the submersible engine from the government. And I ended up in a position where the money came in to build one, and I was in charge of it. So prior to that, I was a design engineer, one of a number of engineers on the effort. Now I was in charge of it being developed, the next generation, by a company. So it's kind of interesting dynamic. So went from the drawing board, if you will, or the CAD, to overseeing other people and in a business as a company's work. So they made a lot of refinements to the design. Here you can see in the design over to the left are planes, actually subsurface. That's a bow plane for vertical stability and control. In the aft, you see a propulsor. There's one on the starboard side as well. So And the surface propulsion on this craft, we decided not to go with the submersible engines, which I thought was a very smart idea. We went with a jet drive with a encapsulated Yanmar 400 horsepower engine. It worked very well, very repeatable, and yeah, quite a nice refined design. That's the cockpit on the craft. Helmsman, if you will, navigator, positions. This is the surface console where the steering wheel is and throttle controls. Behind it and the back displays, that's the console for subsurface operations. So as you ballast the boat down and bring it awash and then submerge it, the operators would turn around, flip a cover, turn down, and they were going the opposite direction for subsurface operations. It made a lot of sense from a hydrodynamic point of view for the shape of the vessel. When we go back, you'll see here, at a pointy end here, which is great for surface craft and cutting through waves and such. But for subsurface application, you want the pointy end in the aft and the more bulbous end in the front. So kind of interesting design. And by the way, there are crafts still being made similar to this in the world. There's one currently being made in the United Kingdom. So this was on a first surface test run. It's a gratuitous shot of me wearing my Gator shirt. This is up in Long Island Sound. The company was based out of Greenport, New York, which is up in Long Island. And a surface shot from a helicopter. I don't have the video clip attached, but one of the things that we worked hard on, besides the shape and hydrodynamics, and you can see some additional fins here that were there for stability, is we spent an extraordinary amount of time on signature, acoustic signature for surface running. So we had the engine, the 400 horsepower Yanmar, going through an extremely sophisticated muffler system, so much so for that you could not hear the vessel coming past you or up to you, except for the wave slap that the water contact with the hull made. You could not hear the engine until you got to the very aft vector, and you could maybe 15 degrees from perfectly behind the craft could you hear a muffled roar. But for the other 80, well, 345 degrees, you couldn't hear anything except the water slap off the hull. So clever design, nicely done. But we didn't do something very well, and this will go to my TRL in just a second. This is subsurface. This was off the Keys, off of Marathon Key, doing some subsurface runs with it. Not a great photo, sorry, but gives you an idea of the capability and also the interoperability with what we call sealed transport device, or STD, which is nothing more than a industrial militarized diving propulsion vehicle. So this is where we had our problem. So when I talk about TRL and understanding your technology readiness level, it really also equates to understanding your risk. You understand the risk of development, but also risk to the whole system, maturity of the entire system. So what we had was a very, very developmental lithium-ion cobalt battery system for subsurface propulsion. And while we had a subcontractor building it, it was the first of its kind. This is far before Tesla ever got into the market, Elon Musk ever building vehicles. We were doing these mass battery systems for this experimental boat. And so what happened is it wasn't ready to go into the boat. We were doing a lot of laboratory tests and vibration, heat sink, cold, cycling, et cetera, et cetera. And we were finding problems with it. And, but it was put back on the boat, unbeknownst to us, by the vendor for a test run. And on charge, they caught fire and they had what they call a runaway, lithium battery runaway. And so it wasn't mature enough to go on the boat. We were using another alternate power source for subsurface propulsion. We were using absorbed glass mat batteries at the time, but the vendor decided he thought it was, or they thought it was mature enough, and it wasn't, and it bit us, as you can see. So understanding those risks associated and how to mitigate the risk is extremely important in development work and design work. And that's what was left of the boat after the fire finally went out. Lithium fires, you can't put them out because they produce their own oxygen and fuel. So they just need a little heat to go off to complete the combustion triad. And so about 3 years of work down the drain because of lack of managing the risk of a subsystem that could and did cause catastrophic damage. Fortunately, nobody was hurt in the process. So we'll move on to another project. This was a far more complex project than a simple craft, a hybrid craft. This was a project in human injury, in trying to understand the attributes of what happened, the contributing factors to human injury, musculoskeletal injury to our special warfare combatant crewmen and SEALs that are on the combatant craft. It's a photo of a rib that we no longer have in inventory, the NSW rib, Naval Special Warfare rib, and it's kind of a famous photograph of it flying through the air. But what we're having is a lot of spinal and major joint, hip, knees, and shoulder problems from this and another boat. Eric Pierce was one of the people. He's a human factors engineer that I hired out of Panama City, where I had worked for before. But we had a team of epidemiologists from Naval Health Research Center. We had University of Virginia Biomechanics Lab involved. We had Duke University. We had Drexel University on this, as well as the boat developers with the Navy, trying to understand what was happening. So when we started this, and this was so many years ago, measurement systems, recording systems were not as prevalent as they are today. So we had to develop our own to measure the dynamics of the body and try to couple it closely with the body. And with some of the international work that I've done with United Kingdom, we did a joint project. We started that in 2009 to try to help them to understand the dynamics to their boat drivers and their equivalent of SEALs. So one of the major factors involved was the debilitation that comes from injury to the spine. Convalescing time, recuperation time is extensive if they can. So we looked heavily at the dynamics of the spine and what was happening. And the spine resonates in about the 4 to 12 hertz frequency range. And so we always were filtering our data for that spectrum. So it's low frequency energy that really causes damage with most of the musculoskeletal soft tissue. And so this was an effort we had with Drexel University, looking at the strain rate of the soft material, especially the intervertebral disc, and the behavior of them going from an elastic, viscoelastic to a plastic state based on strain rate. It's the basic, what is that, Poisson's ratio? Behavior materials based on the strain rate. And there was a correlation, and we're just trying to understand where do we really need to start to understand how to design a mitigation capability from a suspended seat to a boat hull or so forth. So this is just an example of one of the contributing projects or multiple projects that we had on the effort. So let's see if the next, all right, there we go. So I locked up for a second. So this was one of the many things we did. So if I'll back up, we did instrumentation. So we could capture the data of not only the individuals and their pelvis of their body, tightly coupled it, along with looking at the basic physiological limits of exposure to repeated mechanical shock and also individual large shock. to also looking, to seats, suspension seats. And this is an example of one of the things we did. So let me back up. So this is a clip, sorry, it's not functional, of a SEAL squad, or probably, SEAL squad on one of the rib boats underway. And that tells you they weren't doing very fast. They're doing about 30 knots, but in the seaway conditions they were in, they were pounding hard. And so you can see how the guys have to brace themselves. It's not all that conducive to being a sense of security, but the guy's got his left hand on the rail there, another one on the side of the seat bolster. And if they hit a rogue wave, they have a difficult time. And so these gentlemen are repeatedly having, and I have friends that used to do this for a living, and after they retired, two close friends of mine, they've had cervical spine vertebrae fused together, multiple hips replaced, knees replaced. It's just a extremely difficult operational environment. So we were there to try to understand the environment first and to discover a way to mitigate it. So one of the ways we discovered was through suspension seats. And this was one of two different styles that we developed. There was another for a very different craft. This used a semi-active suspension element that adjusted the damping response based on a number of factors, to include the weight of the individual, to include the position of the state or the position location of the damper, and to include the shock that the boat deck was measuring. So it was constantly adjusting to the riding conditions, the dynamic environment. And that's a trace of one of the tests we did. You can see this was back in 2008 outside of Gulfport, Mississippi, outside the boat manufacturer's facility. And you can see the blue trace is the deck. And this, I brought this in because it captured, and this is all low bandpass filter energy. This is not, 100 hertz, 200 hertz energy. This is low frequency energy that is the main point of discussion, concern with the musculoskeletal system. So you can see it spiking 7, 8 Gs, that hurts. It's really the time under the curve that is the total energy. And so you can see from the seat, navigator seat is in red, helm seat is in green, and how we clipped off. You never can get away from the energy. The energy is energy. So you're trying to expand it over time. And so the energy is lessened, if you will, not lessened, but the spike, the acceleration, the jerk rate is lower to the body. And this is what we found through doing our disc work and some other cadaver work, that you have to change the wave shape in order to reduce the injury. And so an example, very complex project from a physiological point of view, from a measurement point of view, understanding the environment. It's an extremely harsh environment. And then putting all those things together for something like seats. And that was our mitigating step with all the knowledge. And this went on for 7 years. This was not a short-term project. And we developed seats. This also resulted in ASTM standard for ride quality, and which we use today to design and build or buy our boats. And so we learned a lot, to include, if you notice on this photograph, it's kind of a wonky looking steering system that was adapted just for these seats, because the seats move up and down. But what is closely coupled with this is the ergonomics and the controls that have to be to work alongside or seamlessly integrate with a moving suspension seat. So these were just prototypes there. The seats were fairly refined, but so it's very complex, very lengthy, working from physiologists to research physicians to engineers to data processors, etc. Very interesting. I learned a lot from it. So one of the other projects that were highlighted early on was dry combat submersible. So because of my background with the Navy, working with the Navy from diving systems and such, and my certifications in Navy diving and Marine Corps combat swimming. I was recruited for this position, and that is I was the first plank holder of the dry combat submersible, or the undersea office. This is one of our first prototypes. We call it the S351 or 351. And we made this in England, and in southern England, where we're in production today. And so this submersible, it's a dry submersible, holds a number of SEALs and also crewmen, 2 crew, and a number of SEALs that ride in the back. It's got a multi-day duration. It travels fairly rapidly through the water. I can't tell you the numbers, but I can say it travels fairly well. You can see on this photograph in the upper right-hand side, this little different lens with these rivets. That's the sonar system, the forward-looking sonar, a couple different arrays in there. And so it was a quite sophisticated design from propulsion point of view, from sonar point of view. And there's also slow speed maneuvering thrusters that are stowed at the moment that you can't see, but also has the capability of locking divers in and out of the craft too. So some people would call it a midget submarine, some people would call it a submersible. But another very interesting project, I was in, as Mitchell said, I was the technical director at first, establishing the technology development strategy, along with also the safety certification process to make sure that we were up to standards, if you will, to make sure that people inside would be safe. And so one of the things that I did is to mitigate the risk, if you will, is I leased a submersible, and I don't think I have a photo in here of that, where I leased a submersible to understand how to do the safety certification. And once we got it certified, I was the first guy down in the boat, along with some other people, just to show that the command and the community, I had faith in the safety of the system. So, okay, now this is, I do have it, I apologize. This is the S301 submersible that we leased, and to go through our safety certification validation process. And that was a lengthy 2-year process. And so anytime the military has a system and you look through all the ways that it can fail through some kind of failure effect mode analysis, you come up with a bunch of things that are of concern to cause injury or death, and you have to come up with some very dependable, reliable mitigation steps, either through the design, materials, procedures, a variety of things. And little things even on a submersible like this that you can lock in and out of. The paint on the interior can be a toxin under different pressure conditions, where it may not be on the surface, but you put the interior under pressure as you're locking divers in and out, and it can off gas terribly on you. So many safety and design details on this these type of craft. So there was, me, this was the maiden voyage of the S301 after it was safety certified. This was March 15th, 2007, I believe it was, somewhere in there. And not 2014, I'm sorry. And so, yeah, that's me. Driving it, yeah, it wasn't all that difficult to pilot during the day. But this is the SEAL that was assigned to my team, and a few of the other people. So you can see the cramped conditions on the inside, and there was a room for a few people in there. But largely, this was a surrogate craft to understand how to do safety certification on a submersible. So on to lethality, which is my current position. I'm the deputy program manager for all lethality systems for special operations, and that includes ammunition, munitions, shoulder fired munitions, every type of small arms that you can imagine, suppressors, optics, thermal vision, nods or night vision, and also precision strike missile systems. So this is the office, my team. This was a year ago at the Nevada Test and Training Range. We held a range event for a number of days out in the desert, shooting all sorts of weapons and doing all sorts of evaluations. So that's my team. There's a little bit of group photo there. And, but so that's where I've, if you talk about the breadth of and job responsibility. So I went from a design engineer to overseeing a team of people on a fairly simplistic, if you want to call the the one submersible boat simplistic, to a very complex, directly leading the team for a very complex project with human injury for our boat drivers, to this being in charge of an office. And I've got 4 lead assistant program managers in there who have their own teams. It's a very integrated across the country network of people. And in fact, next Thursday, I go out and we do this all over again in the desert. But so again, I'm trying to highlight differences throughout a career path from design all the way up through being in charge of a larger organization, maybe not from a corporate level, but from a development and procurement point of view. So lessons learned, I was hoping we would get here. And I wouldn't run long, and I'm not. So for me, in thinking back on my 30+ year career, I've learned some lessons that I think are hugely important for anybody. And I've got a new intern coming in April 1st. I have a new employee that started 2 weeks ago. She's not an intern, but she's still fairly junior in the system. But I go over these things with them. And one of them is learn how to make stuff happen. It just always pays dividends that you can figure out. It's all problem solving. Learning how to make stuff happen means problem solving, and never kind of get stuck into the corner. You have to pull yourself back and think, make things happen, problem solve. Always complete a task. Absolutely, always complete a task. And that goes with number one. Learn how to problem solve. Figure it out, never give up. You can ask questions, definitely ask questions and other people's point of view. And I had one mentor, a gentleman, senior engineer in the Navy named Joe Brown. And I went to Joe from time to time when I had a technical problem I didn't know how to solve. And so Joe would write some notes down, talk it through with me, and give me some ideas. And then he would follow up the notes and throw them in the garbage. And he said, those aren't for you. Go figure it out. And it always helped. So always complete a task. Going in to find a mentor. I just talked about Joe Brown. He was a professional mentor of mine. And wonderful, wonderful experience. Him helping me along the way. I've had other professional mentors and I've had some personal mentors too. Hugely important. It helps you understand where you're at. Sometimes you don't know if you're doing well or not, but it's important to have a mentor. Have a positive attitude. Absolutely. There's nothing worse than having somebody on the team or in the office that's negative. You don't want to be around that person. So be the person that has a positive attitude. It is contagious. It builds esprit de corps, if you will, and it will even make you feel better. By maintaining a positive attitude. And even when things get difficult and problems arise, be calm about it and keep a positive attitude. It means a whole lot, not just to you, but to the entire team. Very important. Next is build a network of achieving associates. Absolutely, because there will be those no matter where you work. Some of the complainers, some are the people that just get by. You don't want to have those people in your network. They may be good folks, but on a personal level. But what you want to have on a professional sense is network of achieving associates, people that get things done, know how to be successful, and you want to be with those people, and not necessarily for your friends. We're talking about work environment. You want to be around achieving associates. Next point is be the value-added person, the go-to guy or person. And that goes along with everything above that, right? Be the person that somebody else in the community or even the organization, if they have a problem or an issue, they'll come to you and ask you, how would you solve this, or what do you think? What's your opinion? And so really you grow to the point where you become the mentor, if you will. Next one is, do not become hostile or argumentative with people. It never pays off. It never has for me. It may feel good at the time, but I have to tell you, you burn bridge, or you'll scorch it, and you'll ruin relationships. And I've had 2 instances in my career where I decided I was going to war with somebody, and both times I was wrong, and it cost me dearly from work relationships point of view. So fortunately, I got that out of my way when I was fairly young. And that goes to the next point: pick your battles carefully. You do not want to be that person known to be the argumentative one. People will avoid you. And then lastly is really know yourself. And like I highlighted early on in the presentation, is the job at Southern Bell as a telephone facilities engineer. Didn't like that job. Absolutely didn't like it. Gave it a year to make sure it was the job that I truly didn't like, and it didn't fit. So I moved on. But know yourself, and what are your likes, dislikes, and seek out a job or employment that really matches you. So for me, as you can see from the different projects that I've been involved with, the different aspects of it, I like change. I like to learn. I really love to learn new things. And in the career path that I've had, it's allowed me to do that dramatically. It's been extremely fulfilling in that regard. So I guess I finished a few minutes early. So if we have any questions.
Yeah, so if our viewers on YouTube would like to go into the YouTube chat, we'll go ahead and answer some questions from the YouTube
Sure.
chat. So we have a question from Kaylee. She said, what is something you know now but wish you knew when you were a college graduate so that you could offer some advice to those that are graduating soon?
I would go back to lessons learned. I wish somebody had sat me down with these points early on, and I'm not saying these are the only points, and I think some of these can be combined. But in my stream of consciousness, this is what popped up. To go at it like this. When I first got out into the working community, didn't know what quite to expect. I really didn't listen enough to the bottom bullet, if you will. I was too worried about feeding myself, so I took a job in a place where I wanted to live, and I was looking for a secure job because I was a poor college student going through. So I was looking for security in a place I wanted to live, and that was Panama City Beach. But then I quickly found out, no, this isn't for me. I've got to find something for me. And I was very, very fortunate that I had in my network of achieving associates a friend of mine that I worked out with in the gym who just happened to be a senior executive at the Navy base, and I had no idea. And we worked out, spotted weights for each other, bench press and such. And he turned out to be a PhD and a senior executive. And he asked me one day, why aren't you working at the Navy? So it was through that network that I got my interview. And on the interview, I got an offer to work for supporting naval special warfare or the SEAL community. And I said, yes, count me in. And so one is build a network. Coming out of school, you have to understand the importance of a network is. And it's not nepotism. It's a matter of people looking for other people they trust and they know they can do a good job. And so build a network, always work on a network, look for a mentor, and then also find a job that or a position that fits who you are. And I've had, one of my cohorts that graduated with me in 1986, he left there and went to be a car mechanic because that's really what he wanted to do. He got his degree, maybe from pressure from his family, I don't know, but he really wanted to restore cars, and that's what he did. So, party on, Garth. I mean, do know who you are and do it.
That's excellent. So we have another question from Kaylee actually. What was the most fun you ever had on a job or project?
Ooh. Ooh, I have a lot. I had a lot. So, submersible boat project, both of them, doing a lot of diving out there, problem shooting and so forth, but operating the boat between Panama City Beach and then down into the Keys. That was fun. A lot of work, but it was very unique, very fun. Um, Most definitely. Doing a lot of international travel. I've traveled from Okinawa to Croatia for work and international. And really didn't highlight. I've been doing for about 17 years international work with partner nations: Australia, New Zealand, Canada, United Kingdom, France, Norway, Sweden, and so that engagement, that work, that's very gratifying to do. And as I mentioned earlier, some joint work with the Ministry of Defense with the best Special Boat Service, very gratifying. Um, Most recently, last June, I was at Fort Knox shooting the advanced sniper rifle. And so we had a dozen special operations snipers out there with their most recent sniper weapon. And we're going through testing with it. And so shooting at three different calibers, three different barrels. And so after the guys had shot hundreds of rounds, I got my turn shooting it with a 338 Norman Magnum barrel and round in it. And I had a very experienced special forces, or most people call him Green Beret sniper, be my spotter, Aaron. And he gave me the windage offsets and the elevation offsets, and I was shooting at 1,000 yards, hitting silhouettes. That was a lot of fun. But more fun than just hitting the targets is interacting with the guys, with the operators, and helping them solve problems or increase capability. And I have to tell you, I've had so many guys that were on the boats, the surface craft, when they found out that I had something to do with the seeds and shock mitigation, came up and thanked me. And so that was pretty cool.
That's fantastic. Thank you. Yeah, Braulio says he doesn't have any questions, but he wanted to thank you for taking the time to do this. It looks like he came up with a question. How do you feel that your job as a laborer helped prepare you for your career in engineering?
Yeah, that's an interesting question. So one of the things I was doing, that was when I was young and dumb, and I started college and quit, and just for a variety of reasons, and I moved far, far away from home and down to Florida for my Midwest roots, and I was barely surviving. Then I got a job at the railroad, and as a laborer, cleaning locomotive engines off and components, and was feeding myself fairly well doing that. But what that helped me to understand is what I didn't want to do with the rest of my life. And so the guys and gals that worked around me, all due respect to them, they were happy as a clam. It just told me that wasn't for me. That's not what I was meant to do. And so what I did is I worked there for 3 years, and I saved money up so I could go to school. So engineering, maybe not necessarily focus on engineering, but I knew I had to do something better for myself.
Excellent. Um, so another question from Brulio. So you've worked on so many projects with so many people. What advice do you have for undergraduate students trying to learn to work effectively in teams?
It's all about the team. I mean, somebody's got to be the leader of the team, obviously, and ultimately decisions have to be made. But when you're young, you tend to be a little defensive because you don't know as much as some of the more seasoned people around you know. And so you tend to be a tad bit defensive, and I would encourage people not to be. I hired a young lady, about a year and a half ago, logistician, and she's maybe 30. She's wonderfully bright and energetic. And she came up to me not too long ago and she said, sometimes I think people are going to realize I don't know what I'm doing. And I said, no, you know what you're doing. We know we're going to grow you. So I would say coming out of school is just be open to things and not be defensive and respect the opinions of everybody. It doesn't mean they're going to be, quote, right, whatever that means, or the best value added, but you'll learn from that. You will definitely learn from that.
That's a great point. And, talking about the defensiveness, and you mentioned earlier in your presentation that there were like a couple times in your career where you realized after the fact that you probably picked the wrong battle to fight. So that goes to one of my questions I had for you. In those instances where you've realized that you picked a fight you probably shouldn't have, how do you learn from that and come back from that to make that part of your advancement in your career?
Well, I think one of the things you have to do is reflect on what led you up to that, and you also have to keep your ego in check. And sometimes it's a matter of frustrations of things you're having difficulties in your own problem solving or timelines or what. It's really having control of your emotions and thinking. And as long as you keep doing those two, you'll be okay. Keep the ego in check. I think ego is important, but also know that it's got its limitations. You have to also be humble. And so, yeah, learning from your mistakes is extremely important. In fact, that's how we learn, is by mistakes. And so, me as a supervisor and such, I was given good advice when I was fairly young. It's okay to make mistakes, just try not to make them twice. And don't be doing anything illegal, immoral, unethical, and don't kill anybody. And if one of your coworkers makes a mistake, help them up and move out and keep on moving forward. So just learn from them is what I'd say, Mitchell.
Thank you. Sierra had a question, probably going back to the boat fire with the lithium batteries. So how could our students learn more about risk management?
Yeah, I don't believe that's part of the curriculum. It certainly wasn't when I was there. And risk management is one of those key things to understand. I was talking about it last night with one of my guys on a precision strike missile system and understanding when to have critical design reviews on things that you integrate in. And understanding how to mitigate risk. And sometimes you avoid the risk and sometimes you can't. And so, that's a good question, because there's whole courses taught in failure modes affect criticality analysis. That is one of the things that you have to look through to understand which items are going to be catastrophic from a functioning or safety point of view. We go through it with every system that we field. For example, the advanced sniper rifle are reviewed what's called a mishap risk assessment. And that's done per a MIL standard, and I'm sure there's commercial variations of this. And you look for all those things that you think can cause harm, catastrophic failures, and you go through all the steps necessary. So there's courses in it, there's documents in it. TRLs and failure analysis go hand in hand. And TRLs gives you a number to help you quantify the risk from a maturity point of view, but also the underlying thing is your risk involved. So that risk, as I highlighted earlier, is that battery system was not ready to go into that mature boat. The vendor did without our knowledge. We were trying to take all the necessary mitigation steps in a very controlled test method, and we kept having subsystem failures. And actually what happened is he had a congresswoman from his district wanted a ride on the boat because that was a congressionally funded effort. And so he brought her and her staff or entourage out for a boat ride on it. And the next day they're recharging it and it caught fire. He should have never put that battery in. So we were trying to do it. I guess where we failed, if you will, is we didn't maintain positive control of the battery system, but it was very hard to do contractually. So I don't know if I answer your question exactly, but if I didn't, let me know.
Yeah, I think that was pretty, pointing to those MIL standards and all the different courses all over the place, and some of the failure mode analysis that you talked about. I think that's a substantial answer. We have another question from Stefan. who asks, what kind of opportunities are there for being self-employed as an engineer?
Oh, wow. Since I've never done it, I don't know if I can give you a great response. I can tell you I've worked with small companies. I know one guy that retired from the Navy as an engineer, and he did his own consulting work. And when you do that, sometimes you have work, sometimes you don't. Um, because while you're busy doing the design work, whatever the aspect of the engineering is, you're not marketing for more work. So when you're an individual engineer, gig work as they call it, I've never done it, but it is not continuous work. Now I've worked with many small businesses, 25 people and less, and the cash flow is always a concern with those companies. And all of them that I worked with were R&D companies developing things. For example, the boat seat that I showed you on the previous slide, the suspension element was made by a company up in New Hampshire named Active Shock. And I started with them on a small business innovation research contract with two people. They had two people, but two brilliant people. And so what I had to do is help them with cash flow. So they were doing great work, always got more value than I normally did for efforts. And I found a way to keep the money and the effort going because cash flow is king for small business.
Yeah, I think it's really interesting to hear about it from not necessarily someone who they themselves worked, um, as a self-employed engineer, but from people who worked with people who were self-employed to get a broad array of experiences. Um, Sierra had another question. Are there any books, experiences, or trainings that you would recommend for learning about professionalism or soft skills?
Wow, soft skills, great term. I'm sure there's a bunch of them. I will tell you that I took a variety of leadership training in the last third of my career. And as I told my supervisors, it should have been my first third of my career. And so this is a really good point going back to these lessons learned. And I learned so much about myself and leadership training and so much about other people. And I wish I would have had that in my 20s. I think I'd have been far more successful along the way, um, if you will, or at least with success in a team and feeling comfortable. When I was younger, as I said, I was a little bit defensive because I knew I wasn't the most experienced or the brightest person in the room. But I know it's okay, and that you keep working on and you work as a team, but you keep pushing hard for yourself and contributing. But those classes that you can take are invaluable to help you understand who you are, but also to appreciate what other people are as well.
Thank you. Thank you, Sierra, for the question. Another question from Brilio, who asks, do you work a lot with electrical engineers? And if so, how did that relationship work?
Oh, certainly. I've worked with nuclear physicists, electrical engineers, anything and everything you can imagine, and even true systems engineer. And what a pain they are. But yeah, you have to. And so when you're talking about teams, you talk about complex systems for like human injury or boat development or whatever. And I've had this ongoing project, which I haven't mentioned, in small arms suppressor technology. And that team I put together two nuclear bomb engineers from Lawrence Livermore National Labs. Actually, we had four, and then a materials PhD out of Oak Ridge National Lab, and then a weapons expert out of Benet Labs with the Army and some others. Looking at the physics inside or coming out the business end of a small weapon. And we use the second largest supercomputer in our country in this multi-physics model to actually empirically adopt it or adjust it so we can model the dynamics of a small arm at rapid fire 600 rounds a second. And we use that as a design tool to build suppressors. Highly successful. It worked. I'm in the process right now of doing a technology transition from the government to industry with that. and we licensed that technology and the use of that computer and software to 12 different companies. And so you want to talk about a very complex group of people, from nuclear physicists to gun manufacturers to engineers, you name it. And they all come from a very different point of view. And I got a retired Ranger that works for me, long tab Ranger. That means he was from the 75th Ranger Regiment. And he's a personality and a force all to himself. So you're talking about this very dynamic education, background, personality, from introverts to maximum extrovert. And you have to learn how to deal with those people. And me as a leader, lead those people. So I'll go back to Sierra's question about soft skills. And that goes back to understanding who you are and appreciating other people. So early in your career, I can't recommend that enough to start to understand that.
Excellent. That was a very robust answer. Thank you. Max had a question about your PE. So do you see value in obtaining your FE license and eventually your PE?
Well, that to me was a personal challenge. And to me, it was a mark on the wall that I made the mark in the state of Florida as an engineer. And the military certainly doesn't require it. Private industry does in many cases, where again, if it's a system fails, it could injure or kill somebody. And so going back, that whole element of failure analysis. But so I did it really to show that I could do it to myself. And so I never used it. I never stamped a darn thing. And I kept it active for a number of years. But I did it to show that I could do it. So
I think that's a good personal goal.
yep.
So Sierra has another question about artificial intelligence. So it's like a booming area of focus here at UF.
Oh yeah.
How much have you used in your career, and what way have you used it?
Yeah, that's kind of the topic du jour. 10 years ago was additive manufacturing, and prior to that was nanoparticles. Prior to that, it was cold fusion and a test tube. Yeah, so machine learning, artificial intelligence, so forth. You can imagine it's not all that important to dumb weapons, if you will. So for me personally, not too much. One of the things I was at a thing called Brainstorm Tech a couple of years ago, put on by Fortune magazine. It's out at the Aspen Institute in Aspen, Colorado, and I was in an artificial intelligence seminar. And so two seats over, this lady who's the CEO of a company that you can make reservations with. She was proclaiming, we have AI in our software. And another fast food chain CEO was there, and he said, we have AI in our ordering software. And then there was a vice president of Oracle there, and he said, I hear a lot about AI, but I never hear anything about the consequence of failure if it doesn't work right. And he said, so if we're talking about applications that we use, in social media, ordering food or whatever, and the consequence of failure is minimal, you don't have to do a lot of testing. But if you're trying to control a nuclear reactor with artificial intelligence, and the consequence of failure is catastrophic to huge population, it's a very, very different formula, if you will, or algorithm you're going to go through. So to me, it really depends on the application, and if it fails, what goes wrong. But machine learning and adaptive behavior of equipment and so forth, you bet. So is it part of some of our stuff? Sure. Is that the key focus? No, the key focus is to have equipment that works better than it did before, to give the soft operators an advantage.
Excellent. So, not having AI just to have AI, only when it
Correct.
actually adds value. Excellent.
Correct.
So jumping back a little bit, you talked about, things going very wrong. So in situations such as with the lithium fire, sorry to bring that back up, but so when something like that just goes so catastrophically wrong, how do you break that news to people who were counting on this to succeed?
Through honesty, right? You have to not only state, initially you have to report to your chain of command what went wrong quickly. Partly in the world that I work in case it gets on in the news or in case somebody got injured, and sometimes people do. And I've had other failures, and I've been in Humvees that flipped over, all sorts of things that were extremely catastrophic, but fortunately nobody was ever hurt or killed. So first off, reporting, being honest, transparent, and then you're gonna have to do some sort of after action report, if you will, to try to understand what happened, what decisions were made that could have been made differently to avoid it. And so actually in my office at work, I have 3 photos, and one was the boat on fire of failures to remind me that even though you think you're thinking through everything, there's something you haven't. And so you do your best due diligence to mitigate those risks. And then I always ask myself, would I do that myself personally? Would I use that piece of equipment personally? And me, yeah, I'm that guy. I will. And but I think you have to be able to put yourself in that position, at least in the business that I'm in. Would I use it? You bet I would, because I'm going to do my due diligence, and so will my team.
Excellent. Excellent. I think you've, put your money where your mouth is with
Yeah,
jumping in that submarine and going underwater with it. So as I just want to ask you one more question.
sure.
So looking at the lessons learned slide, you said you want to be the value added person as the
Mm.
go-to guy. So what do you consider yourself to be the go-to guy for?
Well, it has changed as my career progressed. At one time, is all about human injury, and I had people from around DoD call me up, from the Coast Guard to the Army. In fact, I led an interagency inter-service working group on human injury from both vehicles and boats. So there was a point of time, sorry for that phone. There was a point of time that that's what I was an expert in. But diving systems, I used to be the expert in. Um, Today, I would say it is more the whole well-rounded area of between leadership, basic technology development. I will tell you, not enough people understand the risk of technology development and how to mature it, mitigate it. To a variety of things. Congress, I worked for a period of time. I did not highlight with legislative affairs. And so now I'm that person that people call on for mentorship and opinions, if you will. So, Mitchell, it's nothing specific at this point. It's more holistic and comprehensive.
Thank you. Thank you. I really appreciate that. I really appreciate you taking time today to go through
Sure.
your career with us and answer our questions. Is there anything else that you'd like to add?
The only thing I would say is to, again, know yourself. And there's one thing I wish I would have put in the presentation is you can do far more than you ever think you can. Absolutely far more than you ever think you can. So think further out than you think is possible. Absolutely do it. It's worked for me. And so I never thought I'd get through dive school, but I did. So
That's awesome. Thank you so much, Shawn, for being here with
cool.
us. And I want to say thank you to all the viewers on YouTube for your questions and your participation. Um, so be sure to look out for announcements about future episodes of the MAE Industry Insights with Gator Grad series. Thank you guys for being here today.
Thanks so much.